Hello everyone, in today's video we are going to talk about matrix. So what is matrix? Matrix is a rectangular array of numbers, variables, and both. Order or dimensions describes the number of rows and columns in a matrix. So in our example, 2, 4, 5, 6, 3, 7, 8, 10 is a 2 by 4 matrix. Why? Because it has 2 rows and 4 columns. So the row are the horizontal numbers while the column are the vertical numbers. So we always have the order as row times the column. Now let us have the element. Element is each individual entry or numbers in the matrix. We name the element as A sub mn, where A is the name of the matrix, M is the row number, and N is the column number. So suppose we have this data. A sub 12 says the price of a pizza at Tony's is $10.86. A sub 21 says the price of drinks at Vin's is $1.09. A sub 32 says the price of salad at Tony's is $3.89. Now let's move on to the different matrix. A square matrix is a matrix where the rows and columns are equal. Just like in our example, it is a 2 by 2 matrix. Then in the column matrix, a matrix made up of just one column and any number of rows. So in here, it is made up only of one column. Then we have the row matrix, a matrix made up of just one row and any number of columns. So in here, it is only made up of one row. And main diagonal, the elements whose row number and row number are the same. We also have the zero matrix, a matrix of any dimensions made up of all zeros. Now let's move on to equal matrices. Two matrices are equal if they have the same order and their corresponding elements are equal. So the word matrices is the plural form of matrix. So if there are more than one matrix, we call it matrices. For example, we have 4, 0, 5, negative 3 is equal to 4, 0, 5, negative 3. And if A, B, C, D is equal to P, Q, R, S, therefore A is equal to P, B is equal to Q, C is equal to R, and D is equal to S. However, if we have R is equal to 4, negative 3, 7, and matrix S is equal to 4, negative 3, 7, although they have the same elements, it is not unequal matrices because R is not equal to S because the order of the matrices are not the same. The order of matrix R is 3 by 1 while the order of matrix S is 1 by 3. Now let's add and subtract matrices. Matrices of the same dimensions can be added or subtracted. Add or subtract the element of the first matrix by the element of the second matrix in the same position, and the answer goes in that the same position in the matrix that is representing the answer. So from our example, we are going to add 2, 3, negative 6, 7, plus 4, negative 5, 8, 9. Take note, you can only add two matrices if they have the same order. So in here, both matrices are 2 by 2. so we can add them. So in here, we are going to add 2 plus 4, then 3 plus negative 5, negative 6 plus 8, 7 plus 9. So the answer is, we have the matrix 6, negative 2, 2, 16. That is how we add or subtract matrices. Now let us have another example. So in here, we are going to add again. So we are going to add 8 plus 0 is equal to 8, 4 plus 1 is equal to 5, 6 plus negative 9 is equal to negative 3. So that is how we add matrices. Now let's move on to scalar multiplication. So think of the distributive property for matrices. The element of the matrix are multiplied by a value outside of the matrix. So in here, we are going to distribute 5 inside the matrix. And as we distribute, we are going to multiply. So 5 times 8 is equal to 40. 5 times 23 is equal to 115. 5 times negative 11 is equal to negative 55. And 5 times 16 is equal to 80. So that is scalar multiplication. So let us have another example. So in here, we are going to multiply 2 times 4, which is equal to 8. Then 2 times 0, which is equal to 0. 2 times 1 is equal to 2. 2 times negative 9 is equal to negative 18. So we have the product, which is 80 to negative 80. So let's move on to matrix multiplication. In order to multiply two matrices, the columns of the first matrix must be equal to the rows of the second matrix. Suppose we have matrix A to be multiplied to matrix B. So as you can see here, we have the order of matrix A, which is equal to m times n, or m by n, and the order of matrix B, which is n by p. So in here, in order to foresee the order of the product of these two matrices, it is m by p. So example for this one, we are going to multiply matrix A by matrix B. So we have, in matrix A, we have 4 columns, and in matrix B, we have 4 rows. So we can multiply it. Taking a look at their order, in matrix A, the order is 2 by 4, while matrix B is 4 by 2. So therefore, we can multiply them. So the product, or the order of the product of these two matrices, it is 2 by 2. Now, let us have this example. In here, we cannot multiply matrix A and B. Why? Because in matrix A, we have 2 columns, while in matrix B, we have 3 rows. It should be the number of columns and the number of rows should be equal. Taking a look at their order, the order of matrix A is 3 by 2, while the order of matrix B is 3 by 2. So in here, as you can see, 2 is not equal to 3, so therefore, it cannot be multiplied. Now let's move on to multiplication of matrices. So in here, we are going to multiply 1 by 2 by 2 by 1 matrix. So as you can see here, the number of columns is equal to the number of rows. So the product, or the order of the product, is equal to 1 by 1. It is very important for us to know the order of the product so that we can foresee what will we going to do. So in here, we are going to multiply the row times the column. So 4 times 1 plus 3 times 4. So we have the matrix 19. So as you can see, it is 1 by 1. Now let's move on to the next one. What if we have to multiply a 1 by 2 by a 2 by 2? So in here, the order of the product is equal to 1 by 2. So we already know what to do in here. So in doing this, so we have 2 times 3 plus negative 3 times 5, and then we have 2 times 0 plus negative 3 times 1. When we added 6 plus negative 15, it is equal to negative 9. 0 plus negative 3, it is negative 3. So we are having a 1 by 2 matrix. Now let us have another one, multiplying a 2 by 1 times 1 by 2. And the product or the order of the product is equal to 2 by 2. So in here, we are going to multiply 3 negative 2 by 4, 5. So we shall have a 2 by 2 matrix. In doing this, so we are going to have 3 times 4, then 3 times 5, negative 2 times 4, negative 2 times 5. So the product is 3 times 4 is 12, 3 times 5 is 15, negative 2 times 4 is negative 8, and negative 2 times 5 is negative 10. So we really have a 2 by 2 matrix. Now let us have a 3 by 3 times a 3 by 3 matrix. So as you can see, we are just going to multiply the rows times the column. Now let us have a 1 by 3 times a 3 by 2. So in here we are going to multiply 1 times 2 plus 4 times 5 plus 6 times 7, which is equal to 64. Then we are going to multiply 1 times 3 plus 4 times 8 plus 6 times 9, which is equal to 89. So we have a 1 by 2 matrix. Now let us multiply a 2 by 2 matrices. So let us multiply 1 times 5 plus 2 times 7, then 1 times 6 plus 2 times 8, then 3 times 5 plus 4 times 7, then 3 times 6 plus 4 times 8. So we have 19, 20, 43, and 50. So the product of a 2 by 2 matrices, when you are going to multiply it, is also a 2 by 2 matrix. So if the matrices pass the first test of the columns in the first being equal to the rows in the second, use the following steps to multiply. So multiplying a 2 by 2 matrices. So since the number of columns is equal to the number of rows of the second matrix, so we can multiply them. So in multiplying this one, we have 2 times 4 plus 3 times 8. And then 2 times 5 plus 3 times 9. And we have 6 times 4 plus 7 times 8. And then 6 times 5 plus 7 times 9. So 2 times 4 plus 3 times 8 is equal to 32. And 2 times 5 plus 3 times 9. So 10 plus 27, it is equal to 37. And 24 plus 56, it is equal to 80. Then 30 plus 63 is equal to 93. So take note that when we are going to multiply a 2 by 2 by a 2 by 2 matrix, the order of the product of the matrix is still a 2 by 2 matrix. Now let's move on to solving matrix equation involving multiplication of two matrices. First, in here we are going to multiply P2 negative 3, 1 by 2Q. In doing this, so we have 2P plus 2Q negative 6 plus Q is equal to 12, 4 plus 2Q. And then we are going to apply the concept of equal matrices. So we have one of the equations, which is negative 6 plus Q is equal to 4 plus 2Q. Transposing 4 to the other side as well as q to the right side of the equation, we have negative 6 minus 4 is equal to 2q minus q. Simplifying further, negative 6 minus 4 it is equal to negative 10. 2q minus q is equal to q. So therefore, q is equal to negative 10. And then we are going to use the next equation, which is 2p plus 2q is equal to 12. Substituting the value of your q, which is negative 10. So 2 times negative 10 is negative 20. Transpose it to the other side. We have 2p is equal to 12 plus 20. Then simplifying further, so we have 2p is equal to 32, dividing both sides by 2. So p is equal to 16. Now let us have transposing a matrix turns rows into columns. So we have the transposition. So in here, the original row becomes the column, and the second row will become the second column. So originally it is 2 by 3. Now it is 3 by 2. So in here, if we have matrix A, which is 1, 2, 3, 4, 5, 6, when we are going to transpose it, it will become A to the T, meaning it is already transposed. So in transposition of matrix, we are going to interchange the rows and columns. So the original row 1, 2, 3 will become the column 1, 2, 3. And the original row, which is 4, 5, 6, will become a new column, which is 4, 5, 6. So the order of the original matrix, which is A, it is 2 by 3. Now that it is transposed, the order of A to the T, it is 3 by 2. That is transposition of matrices. So that's it for now. Thank you for watching. See you again next time. Bye.